Today we will observe how a 555 timer IC can be used as a monostable multivibrator. The pin configurations are 1 ground, 2 trigger, 3 output, 4 reset, 5 control voltage, 6 threshold, 7 discharge, 8 plus VCC. In this configuration, it is slightly different from a stable multivibrator circuit because of its trigger input. Here you can see pin 2 is used for trigger input and pin 3 is for output and connected to LED through 100 ohm resistor, and another part of LED is directly connected to ground. For 555 IC we observe a negative edge trigger. In this figure we observe a push button, normally NC, and when we push it down it breaks the circuit. Here part A of the push button is directly connected with plus 5 volt DC. In this figure we observe B part of the push button has plus 5 volt DC supply, and this part is directly connected to pin 2 of 555 timer IC. The push button changes its state from NC to NO. The trigger input goes low from plus 5 volt to 0 volt, and the output goes high from 0 volt to plus 5 volt at this particular time. Due to this negative edge trigger, the output goes high. Here the pulse is going down, pin 2 gets low voltage, 3 gets high voltage and sustained for some time. Now we are going to other configuration of the circuit. Here RA and C is the main part. RA is directly connected to between 7 and 4. 4 and 8 is directly connected to VCC. RA can be chosen according to TP. TP is a peak time. So, okay, now explain what is TP. It's a timing diagram of input-output characteristics. It is clearly observed when the trigger input goes down, the output voltage goes high. Here it is plus 5 volt. Suddenly it falls down. When it falls down, at that particular time the output voltage goes high and sustained for some time, and after some time it falls down. That is TP. This particular time is called TP. Here we can represent the TP is equal to 1.1 RAC, and every fall time the output goes high and sustained for some time. Every fall time our output rises and rise time is TP, and our clock period denoted by T, and this T is TP plus off time, and this T is variable because our TP is same in every trigger input. If our triggering input is same, then our total clock period will be same. If our triggering input is not same, then we will get variable clock period. Suppose here it is T1. Here we can see T1 is not the same as T, but here TP is same. It is 1.1 RAC. In every time TP is 1.1 RAC. By changing RA and C, the TP can also be changed. And also we observe this basic principle used in many industry. So we can measure the TP for monostable multivibrator, and this is the basic difference between monostable multivibrator and astable multivibrator. For astable multivibrator, the output frequency varying continuously, but in case of monostable multivibrator, we get TP, there is a rise time for every trigger input. By this configuration, we can make high our output continuously. Here we know our trigger input is negative edged. When we trigger it, this negative edge creates output high. This is negative edge trigger, and we sorry, that's right, negative edge, and our output for due to this negative edge sustained for some time, goes high and sustained for some time, and at this second trigger again it goes high, and after TP it falls down. We observed it previously, but in case our trigger comes fast, here my triggering input is much faster. The time of the next trigger comes after the previous is less than TP. After every triggering, IC counts TP, and if we trigger again before that output goes low, the timer counts from the first. After the last triggering, timer counts TP, which is 1.1 RAC, and it will make output low, and we get a continuous output range. So by frequently triggering, we can make the timer IC output high continuously. This principle can be observed in the zero speed switch system in the industry. In my last video, I have explained what is zero speed switch and how it can work. It is clearly shown in this timing diagram that our output goes high only for negative edges. Though there is low pulse continuous in pin 2, our output remains low. If you like this video, please subscribe. Thanks for watching.